Integrated Math 3, this is assignment 2.02 factoring polynomials. This is the solutions video. It's also going to kind of double as the instruction video until I get the actual instruction video made. But this is what you really need to do to turn it in. And if you want a copy of this assignment printed out like this, you can come see me at Hoover on Monday, Wednesday, or Friday and pick one up. But you can simply do this on line paper. If you choose to do that, that's perfectly fine. Go ahead and copy this heading pretty much exactly as you see it up here, including the assigned and due dates. Now this is for the Monday, Wednesday class. I'm going to have a separate version for the Tuesday, Thursday class, which it's exactly the same, except it's going to have the due dates, assigned and due dates for Tuesday, Thursday. Otherwise, it's confusing. If I try to put two due dates, I think it's just confusing. So I'll have a separate version for Tuesday, Thursday, okay? There you go. So that's that. So let's go ahead and get started. So what is factoring? Let me just give you a quick example of what factoring is. When you expand up to binomials, for example, x plus 2, x minus 3, those are factored binomials. And to expand them, you FOIL. X times x is x squared. X times negative 3, so it's first, then it's outer. It's actually, first outer, which is negative 3x. Then it's the inner 2, the 2 and the x, so it's plus 2x. And then it's last, 2 and negative 3. That's FOIL. That's negative 6. The two terms in the middle always combine, so negative 3 plus 2x is negative x. And then you have the negative 6 there and the x squared there. So this, go from this to this, is called expanding. That's expanding a polynomial. And what we're going to be doing today is going from this to this. And that's called factoring. You're breaking it apart. That's what factoring is. Okay, so that's really what this lesson's about, is going from something that looks like this, and there's a variety of them, not just looks like this, to something that looks like this, that's broken apart. Okay, so to do that, what you have to do, these are called terms, coefficient, variable, exponent. You have to find what these two terms have in common, and then you can pull it outside. So I'm going to start off by putting this in a parenthesis. Now, to factor regular numbers, you have to find the largest number that goes into both 8 and 10. So 2 goes into both 8 and 10. 4 goes into 8, but it doesn't go into 10. It doesn't go in evenly. I mean go in evenly, an even number of times. 5 doesn't go into 8, but it does go into 10. So there's nothing else. The biggest that we can get is 2. So I'm going to write the parentheses down here, and I'm going to bring a 2 out here like that. So I brought a 2 out of here, a 2 out of here. Now, the other thing you want to do is you want to bring out whatever you can from the variable. So here we have an x squared, and here we have an x. And you ask, what do those two have in common? What's the common number of x's that you could pull out? So what we're saying is this. X squared is x times x. X is just x. So what does this and this have in common? They have a single x in common. Okay, you can't pull two x's out of that guy. He doesn't have two x's. So we're going to pull an x out. So what we've pulled out is a 2 and an x. A 2 is the largest number that goes into both 8 and 10 evenly. And an x is the largest of these two variables that they both have in common. All right, so now what you have to do is work backwards. How do I get from 2x to 8x squared? Well, let's take it one part at a time. 2 times what number gives you 8? And that answer would be 4. Now what about the x? X times what would give you x squared? Well, x times x equals x squared. So x times x would give you x squared, so I'm going to put an x there. So 2x times 4x equals 8x squared. Now we need to get 2x plus something gives us 10x. Well, we don't need to multiply it by anything x down here because we already have an x there. So it would be x times 1 would be x. 2 times what gives us 10? And of course that would be 5. So that is the factored form of this. So how do you check your work? If you didn't have a solutions video, you go ahead and you expand it again. So 2 times 4 is 8. X times x is x squared. 2 times 5 is 10. And then you have the x multiplied through as well. So it's 8x squared plus 10x. That's what we started with. So that means that's the correct answer. So this is the answer. This is simply the check. You check to see that this produces what you started with up there, okay? That's a check. All right, let's keep going. This one is 12y minus 16. Well, they clearly don't have any y's in common because this one doesn't have any y's. So the only thing we'll be able to factor out is something about the number. So the question you ask is, what is the large? First of all, you ask, what's the largest number? Yeah, that goes into both 12 and 16. So the first one you want to check is 12. It's the smaller of the two numbers. Does 12 go evenly into 16? No. So then go down, go backwards, go to lower numbers. What is the largest number that goes into both? I can see that 2 will go into both because they're both even numbers. But there's a bigger number that will, and this is part of why this is valuable. I think factoring polynomials, you'll never do that in life, but you're developing some number sense, being able to look at these numbers and say, okay, what's the largest number that'll go into 12 and 16? And that can be valuable when you do regular math on a job sometime. Okay, so what is the largest number? Well, it's going to be 4. If you weren't sure, just try out numbers. 3 goes into 12 but doesn't go into 16. 4 goes into both of them, okay, but is that the largest number? 5 doesn't go into these. 6 goes into 12 but not into 16. 7 doesn't go into either one. 8 goes into 16 but not into 12. And once you get beyond 8, then nothing would fit into either of them, okay? So what we are going to do is pull that 4 out, put our parentheses here, pull the 4 out. So 4 times what gives us 12? That would be 3. And then we have to have the y land there, so we put that inside as well. So 4 times 3y equals 12y. And now over here it's a minus sign, so I'm going to write that. 4 times negative what gives you negative 16? That would be 4. And again, you can check your work by multiplying this back through and seeing if you get that. Okay? All right, let's go to this one. Okay, this one looks kind of messy. It's not too bad. It's got negative signs and kind of big numbers and big exponents, so it's not too bad. So the first thing we're going to deal with is with the numbers, the coefficients. So the first thing you want to ask is, forget the negative sign for a minute, does 15 go evenly into 45? So let's check that on a calculator. So I'm just pulling out a calculator. 45 divided by 15. Let's see if it gives us a whole number answer. It does, 3. It goes in exactly 3 times. So that means 15 will go into 15. It will also go into 45. So I'm going to factor out a 15 because both 15 goes into that, it goes into that. The question is, do I factor out a negative 15 or a positive 15? I'll explain at the end of the problem why I chose negative 15. So we're going to factor out a negative 15. So here we go. Negative 15 is out there. Okay, now let's go to the d. We got a d to the 5th and a d to the 3rd. So what do they both have in common? So let's write it out. What does d to the 5th equal? It equals d times d times d times d times d. That's what d to the 5th means. What is d to the 3rd? It's d times d times d. Okay? So what do they both have in common? They both have these d's, these 3 d's. So they both have a d to the 3rd in common. So that means we can pull out a d to the 3rd. Can't pull out a d to the 4th or d to the 5th because this one over here doesn't have that. So what you pulled out is negative 15d to the 3rd. So what you now need to do is work back in this direction. Negative 15d to the 3rd times what gives you negative 15d to the 5th? Well, the negative 15 is already there, so you don't need any number inside here. But d to the 3rd times what equals d to the 5th? And the answer is, you just got to remember your principles of exponents. It would be d squared. So let me show you over here. Again, the principle of exponents says d to the third times d to the second equals d to the 3 plus 2. Not multiply, not times 2. I'm sure I stay on screen here. Okay, which equals d to the 5. Okay, so that has to be d to the second. D to the third, d to the second gives you d to the fifth. Now down here, we said 15 went into 45 3 times, so this is going to be a 3. But we need to make it a positive 45. So negative 15 times negative 3, got to watch your negative signs, will give you positive 45. And then we have a d to the third here, but we're going to multiply also the negative 15 d to the third. So since you already have the d to the third here, you don't need any more d's here. D to the third times 3, or negative 15 d to the third times negative 3 is going to give you positive 45 d to the third. So there it is. I'm just going to draw my parenthesis a little closer there. Again, let me FOIL it out and be sure. Negative 15 d to the third times d to the second is negative 15 d to the fifth. And negative 15, negative 3 is positive 45. And then the d to the third gets multiplied by that as well. It goes there. And we ended up with the same thing we started with. So that's what you want to check. So this is the answer that they're looking for. This is just the check. Okay. Let's go ahead and do 4. So what do they all have in common? Well, this first term is c times c times c. The second term is c times c. And the third term is just c. So what do they have in common? They really just have the one c in common. So that's what you can pull out of the parenthesis, okay? So I put the parenthesis there. I'm going to put it again there. I'm going to pull the c to the outside. So c times what equals c to the third? That would be c squared. In other words, c to the first times c to the second equals c to the third. You add the 1 plus the 2, and that gives you 3. Okay? C times what gives you c squared? Well, that would be c times c. C times c is c squared. And this last one for some students is the trickiest. C times what gives you negative c? You don't need any more c's. You already have a c there and you have a c there, just 1 to the first power. So what do we need to do to get the negative sign? You have to have a minus 1 there. So that is the answer to this. All right, we're moving on to problem 5. This is what's called a quadratic. That means the highest exponent, the largest exponent is a 2. You worked with that a lot in integrated math too. Okay, so factoring this. Well, one thing we notice right away is there's no n down here, so you can't factor out an n. Unless all of them have an n, you can't factor an n out. So the only thing you can factor out is a whole number there. So the question you have to ask is, what's the largest whole number? The largest number that goes into 6, into 30, and into 42. So the first one you want to try is this number right here, the smallest of the 3 numbers. So does 6 go into 6? Of course. Does 6 go into 30? Yes, it does. If you're not sure, divide 30 by 6 on your calculator and see if you get a whole number, and you will. It'll be 5. And finally, does 6 go into 42? Do the same thing. 42 divided by 6, you'll get exactly 7. So 6 goes into all 3 of those numbers evenly. So I draw my parentheses. Now I come down here, and I'm going to bring the 6 out. So 6 times what gives us n squared? N squared. Okay. 6 times what gives us negative 30? It's got to be a negative number to turn it into a negative. So it's negative 5. And then you have to have that n up here. So that n, since it wasn't out here, has to be in here. So in other words, the n squared stayed inside and the n stayed inside. You didn't pull them out, so they stayed there. And finally, 6 times what gives you 42? We said that was 7. Okay? And that's the answer to that. Now, one thing you might ask is, can you factor this quadratic? We're going to do that in this lesson later on, but I'll just tell you right now, if you tried, the answer is no, you can't factor that. So we're going to learn how to factor it, and then if you wanted to come back to this, you could prove to yourself you cannot factor that. So this is the final answer right here. All right. Now we're going to come down to something that's called factoring a cubic Cubic means the largest exponent is 3. So factoring a cubic by grouping. And what you're going to do is you're going to actually do 3 sets of factoring here to get to this answer. All right, so they give you, this only works for very specific problems. You're going to see what the characteristic is here in a second. So what you do is you group these two together. You put a parenthesis around it. Next, you group these two together. So first you're going to factor this. That's going to be your first factor. Next, you're going to factor this. That's going to be your second factor. And then in just a moment, you'll see what your third factor is. But you factor 3 times. Okay, so just focus on this one right here. What do they have in common? Well, they don't have numbers in common. There's a 2 there. There's nothing over there. So you can't factor out the 2 or anything else. But they have an x to the third and an x squared. Again, I'll draw it again. X to the third is x times x times x. X squared is x times x. And if you group them together like that, you see that what they have in common is an x squared. They both have an x squared. So now what you can do is pull that out. So I'm going to put my parentheses here. I'm going to pull an x squared out. And now I have to work backwards to see what's still inside there. So x squared times what will give me x to the third? So again, come over here if you need to do it. X squared times x to the first equals x to the third. You add the 2 exponents. So that would be x squared times x would give us x to the third. Now x squared times what would give us 2x squared? Well, you already have the x squared. You don't need any more x's. You just need the 2. So it would be plus 2. So x squared times 2 is 2x squared. Okay, let's come over here and do this one. So this one's a lot easier. You can kind of look at this. What do these two have in common? Well, let's take the numbers. What number will go into both 4 and 8? What's the largest number that goes into both 4 and 8? And I think you can all see that that's going to be 4. So that comes outside of the parentheses. And then what stays inside is 4 times what gives us 4x? That would be x. Plus 4 times what gives us 8? And that would be 2. Alright, so just convince yourself if you expanded these, you'd end up with this. And if you expanded this, you'd end up with that. Okay, now what I'm going to do, I'm going to use square brackets. That's a little unusual, but I want to distinguish it from the parentheses here, so you see which is which. But I'm going to treat them, these are effectively just parentheses. So now you have 2 more polynomials, 2 more terms, this one and this one. What do they have in common that we could pull outside of the square brackets right there? I think it should jump out at you. They both have an x plus 2. So I can factor x plus 2. So that's my third factor. Remember I said I was going to factor 3 times? This is the third time. So I bring the x plus 2 out. And now what's left inside my square brackets? The x squared is, and the 4 is. So this is x squared plus 4. And really, to write it appropriately, you should convert that back to a rounded brackets, but it doesn't, or parentheses. It doesn't really matter. Again, the reason I used the square ones so you could distinguish them from these right here. Okay, there you go. That's your answer. If you want to expand that out, you can do it, and you should get back to this whole thing up here without the parentheses. Just what you started with exactly right there. Okay, let's keep going. Let's do this one. Now this one's the same as the one above, except it has some minus signs. You always have to be careful of negative signs. They mess up students all the time. So I'm going to go ahead and group. Okay, so now I'm going to come down here. I can see that 2 goes into 2 and 2 also goes into 6, so I can factor a 2 outside of that first set of parentheses. And I have, just like I had above, I have an x third to the third and x squared. So the thing that they have in common is x squared. So now I work backwards to get here. So 2x squared times what gives you 2x to the third? That would be x. 2x squared times x to the first gives you 2x to the third. You add the exponents. 2x squared times what gives you negative 6x squared? Well, I already have the x squared, so I don't need anything with an x in it. So I got to have 2 times what gives you negative 6, and that would be negative 3. Now I have the plus sign. Now we're going to do the same thing on this one. It looks a lot easier. So what will come out of this? What number goes into, what's the largest number that goes into 3 and 9? That would be 3. There's no x here, so you can't factor out any x's. So 3 times what gives you 3x? 3 times x. And 3 times what gives you negative 9? That would have to be negative 3. So as you noticed before, we have an x minus 3 and an x minus 3. If you didn't end up with that, you couldn't do this factoring. So it requires very specific equations to do this. Okay, so I'm going to put the big block around it here. And we see that the term that this and this have in common is the x minus 3. So we're going to pull that out of the square brackets. And then what did I leave behind in the square brackets? 2x squared plus 3. All right, make sure I'm on screen here. And again, you can convert that back to rounded brackets. It's just not that important, but that's the appropriate way to write it. Okay, there you go. So there is your answer. All right, let's keep going. We're doing good. Okay, this is another one. It's done exactly the same as 6 and 7, so I'm going to make this a U problem. This is one I'll check up on to see that you know how to do this. It's done exactly the same way as the other two. All right, now we're going to start getting into factoring a quadratic. A quadratic is an equation where the largest exponent is a 2. You did this back in integrated math too, but we're doing it a little bit more now, all right? So, let me introduce you to a couple of terms. First of all, whenever you have an x squared or anything that doesn't have a coefficient, there's an implied coefficient of 1. It's there, you just don't write it, but I'm going to write it right now for a reason. Because what we're going to try to do is come up with something called the grand product. It's a big fancy name. And what the grand product is this number times, I'm writing the word times because x looks like a variable. I don't want you to confuse the x with the times sign. Times this number, 1 times negative 24. So for this problem, it's 1 times negative 24 is negative 24. So again, the grand product is the coefficient on the x squared term times whatever the constant number down there is. In this case, it's 1 times negative 24. So now what we're going to do to factor this, we're going to break it out into 2 binomials. It's going to look something like x plus some number. I'll just put question mark. That's what we're trying to find. And x, it could be plus or minus. So let me put, that's a plus or minus sign. And this is x plus or minus some number. Not necessarily the same number there. Those are called binomials, okay? So that's kind of what we're looking for, something that looks like that. So here's what we do. We need to find 2 numbers that multiply to the grand product. They also have to add to this number in the middle right here that's in front of the x. They have to add to that. That's positive 5. Now, some teachers teach you something like this with an X or a diamond or something, and they say, okay, negative 24 multiply, plus 5 add, what are those 2 numbers? But that doesn't help you to find them. It just structures what you're trying to do, but it doesn't help you to find them. So I'm going to show you a way to find it every time if you're, if your math is a little shaky. Here's my first observation. If 2 numbers are going to multiply to negative 24, then one of them has to be positive and one of them has to be negative. And the absolute values, if you take the absolute values of the two numbers, the absolute value of the positive number has to be bigger than the absolute value of the negative number. So let me just give you an example. If I take the number -4 and 2, okay, that's 2 is greater than 4 because it's a positive number. But if I take the absolute value of 4 and that, this gives me 4 and this gives me 2. So the absolute value of these two numbers, this is greater. So here's what I'm getting at. We have to find, I know that the smaller of absolute value of the two numbers is going to be negative, and the greater one's going to have to be positive because it adds up to a positive number. If it was the other way around, the greater of the two was negative, it would add up to a negative number. So that means what I'm going to do is I'm going to start over here by finding two numbers that multiply to -24. If this didn't make sense, don't worry about it. Just watch the example how I do it. I'm going to start with -1 times +24. -1 times +24 equals -24. Now I have to see if these two numbers add to 5. So I'm going to say -1 plus 24, which is really 24 minus 1, equals 23. So no, that does not add to +5. So now I'm going to go down to the next number, -2. -2 times 12 equals -24. Every set of numbers I pick has got to multiply to -24. That's why I'm picking them. Now I say, okay, -2 plus 12, which is the same as 12 minus 2, equals 10. Okay, 10 does not equal +5, so we go on. How about -3 times what? Well, it'll be -3 times 8. Okay, so you come over here, -3 plus 8 equals +5. And that's the one that I want. +5, that's what I'm trying to find. So these are my two numbers, -3 and 8. So what you do is you come over and you write two binomials in this form. X minus 3 times x plus 8. And that's your answer. Let's prove it. Let's FOIL it out. X times x is x squared. This is just a proof. It's just to check the work. X times 8 is 8x. X times -3 is -3x. And -3 positive 8 is -24. And these two middle terms always combine. So plus 8 minus 3 is plus 5. X minus 24. And then I have the x squared in front. So this is the same as the equation that I started with there. So this is just to check. This actually is the, this actually is the answer. That's the answer. This all down here was just checking the answer to see if I got the original equation. Okay, so that's how you factor that. All right, let's do another. See if you can do this one on your own. You can always pause the video, give it a try. You don't have to spend forever on it, but give it some effort to try this because you're going to have to do it on a test. So what's the grand product? Again, I'm going to write a 1 there. So it's 1 times 20, so I'm just going to call that grand product is equal to 20. 1 times 20. So I come over here and I have to multiply to the grand product 20, and I have to add to, they have to add up to this number right here, -9. So let's reason that out. If two numbers multiply to a positive number, they both have to either be positive, or they both have to be negative. Both positive or both negative. If they add up to a negative number, then I know they have to both be negative in this case. Okay, I can't have two positive numbers add up to -9. So let's go ahead and start with the smallest, -1 times -20. They have to both be negative. That's a negative sign there. That gives you +20. And -1 plus -20 equals -21. Okay, that doesn't equal -9. That's what we're shooting for right there. Okay, so how about -2 times -10? So that multiplies to positive 20. Negative 2 plus negative 10 equals negative 12. That does not equal negative 9. So let's go to 3 doesn't go into 20. So let's go to 4. Negative 4 times negative 5. Okay, that gives me positive 20. Negative 4 plus negative 5 adds up to negative 9. So this is the one we want, and these are the two numbers that we want. So you just simply come over here and write x minus 4 times x minus 5. By the way, did you have to write the x minus 4 first and then the x? No, it doesn't matter. You could have put those in either order. Up here, you could have put those two in either order. X plus 8 times x minus 3 would have been fine. Okay, you could FOIL it to verify that it gives you that, and that's it, but you don't have to do that. Okay. All right, this one here adds a complication, and it's a slightly different way to do it. Not totally different, just a little bit of a twist here. So what you notice is you still have a quadratic, but now you have a coefficient that's not 1 anymore. It's not, you see a number here now, whereas you didn't before. So that means the coefficient here is 3. So what you do is you still find the grand product by multiplying these two numbers together. So I'll just abbreviate that as GP. So that's going to equal, the grand product's going to equal 12. 3 times 4. So we come over here and we multiply to 12, and you add to 8, negative 8, okay? So again, it's similar to the last problem. If two numbers multiply to be a positive number, then they either both have to be positive or both be negative. And since they add up to be a negative number, they must both be negative, okay? So I'm going to start just working negative numbers here. So let's start with negative 1, negative 12. You multiply those two together, you get positive 12. Negative 1 plus negative 12 gives you negative 13. That doesn't equal negative 8. Next is negative 2 times negative 6. That multiplies to positive 12. Okay, over here it's negative 2 plus negative 6 equals negative 8. So there you go. That's what we were trying to get. So they're the two numbers, negative 2 and negative 6. Now there's a little bit of a trick here. Here's how you do this. I won't explain why this works. You don't really have to understand. You just have to know how to apply it here. If I showed you why it worked, it would take me a page of writing out stuff, and it would just be confusing. So here we go. You take 3x, not 3x squared. Take just the 3x and you write it here, and you write it over here. Now you take each of these numbers that you came up with over here and put it down underneath. Okay, and then you reduce these like fractions if you can. So 3 over 2 does not reduce. So what you do is you turn that into a binomial. Now normally you can't just take a fraction or a ratio like this, one thing over another, and turn it into this. But this is what you're going to do here. It's 3x minus 2. Okay? Why that works, you do not need to worry about. It just does. But it's not normal math to say that you could take something over something else and do that to it. That doesn't apply to any of the rules of math, except if I were to prove to you, I could show you a proof that this gets from here to here, but I'm not. Now on this side, you do have something that will reduce. 3 over 6 will reduce to 1 over 2. So this would be 1x, and you don't have to write the 1, over negative 2. So that equals x over negative 2. All right, so now that I'm going to turn into a binomial x minus 2. And that is the solution, the answer to the problem. Let's verify it with a FOIL. 3x, FOIL first, outer, inner, last. So the first is 3x times x is 3x squared. Now the outer, 3x times negative 2 is negative 6x. Now the inner, negative 2 times x is negative 2x. And now the last, negative 2 is positive 4. And the two middle terms always combine. So negative 6 plus negative 2, or negative 6 minus 2, is negative 8x. And then I still have the 4 down here, and I still have the 3x squared here. And you can see that that is exactly what we started with up here. Okay, so again, this part of it was just check. So this is answer. That's required. This is check. This is optional. Okay. All right. So that's how you do those when you have a coefficient in front. Let's do another. Let's kind of do it a little faster. Grand product is these two. So I'm just going to abbreviate that GP. Grand product, that's 12. So come over here, you're going to multiply to 12. And you're going to add to 7. So to multiply to a positive number, they both have to be positive or negative, both have to be positive or both have to be negative. Since they add up to a positive number, we know they're both going to be positive, so I'm only going to deal with positive numbers. So here we go. 1 times 12 equals 12, and 1 plus 12 equals 13. We want it to equal 7, so that's not the one. 2 times 6 equals 12, and 2 plus 6 equals 8. That's no good. That's not the one we want. We want 7. Let's go next. 3. 3 times 4 equals 12. 3 plus 4 equals 7. That's the one we want. So these are the numbers we want, 3 and 4. So now we come over here and we take the 2x, not 2x squared. We come down here and we write the 2x twice. And we put the 3 underneath this one and the 4 underneath this one. So now from this, we can just magically convert this into our two binomials. First of all, see if anything reduces. 2 over 3 doesn't reduce. So your first term is going to be 2x plus 3. Now 2 over 4 cancels. So that becomes 1x over 2. It just reduces down. 2 over 4 equals 1 over 2. And of course, you don't need to write the 1, so it's x over 2. So that's going to be turned into our other binomial, x plus 2. And that's the answer. And if you want to check it, you can FOIL it out, and you should get back to this, okay? All right. Number 13 is U. That's a U problem. Okay, I'm going to leave you to do this one. I'm not going to show you this one, all right? But again, you can check your work. When you get your answer, FOIL it out like I did up here, and see if you get back to this original equation. So you don't even need me to give you the answer to know if you have it right or not. You can check your own work. Okay, since I left you to do the last one on your own, this is the same type of problem. I'll go ahead and do this one with you. So, grand product is 6 times 5. $30. So you want to multiply to the grand product. And you want to add to the number in the middle. That's negative 17. Since two numbers that multiply to be a positive number are either both positive or both negative, since they add to negative 17, they have to both be negative. So again, there's a lot of possible combinations to get 30, so we just start at the beginning. Negative 1 times negative 30. Negative 1 plus negative 30. This equals negative 31. That's not what we're looking for. Okay, the next combination that multiplies to 30 is negative 2 times negative 15. That equals positive 30. Negative 2 plus negative 15, it equals negative 17. Watch out for the minus signs. Okay? And that's what we want. We want negative 17. So negative 2, negative 15 are the numbers that we're looking for. So we come over here and we take the 6n, I keep writing this just to really kind of grind it into you here. 6n squared. It's not 6n squared, it's 6n. So 6n over negative 2. And we also have 6n over the other number we got over here is negative 15. So this reduces. 2 goes into 6 3 times, goes into that once. So this reduces to 3n over negative 1. 6 over 2 equals 3 over 1. For this one, 3 goes into 6 2 times, and it goes into 15 5 times. So I can reduce this down to 2n over negative 5. Okay, I divided this by 3, and I divided this by 3. Okay, and there you go. So now you have this and this, so you can write the two polynomials. 2n minus 5. And that's the answer to that. Okay, so hopefully you understand how to do these now. If you watch some YouTube videos on doing this and they don't use this method, it's a nightmare. It is a nightmare trying to find what these numbers are. Not so much these numbers, but trying to find out what these are on the front there and what these numbers are. Okay, so now you know how to do those the easy way. All right, the next problem involves something called the difference of squares. So these numbers are small enough that I think most of you could recognize that 4 is a perfect square. It's 2 squared. 25 is a perfect square. It's 5 squared. And of course, x squared is a perfect square. It's x squared. So everything here is a perfect square. So what you do is there's a property that a squared minus b squared equals a plus b times a minus b. So that's how you would factor a perfect square like this. The trickiest part of this problem is figuring out what is a and b here. So this is a squared. So a is the square root of this whole thing. So what is that going to be? Well, the square root of 4 is 2, and the square root of x squared is x. So that's a. Again, let me say that again. In this formula, a squared plus b squared, this would be a squared plus b squared. Or it's a squared minus b squared, excuse me. A squared minus b squared. So this is a squared. So if this is a squared, a is the square root of everything you see here. The square root of 4 is 2. The square root of x squared is x. And b is the square root of 25. Not negative 25. There is no such thing. But it's the square root of 25, which is 5. Okay? So that's a and b. So now you can go ahead and just simply, that's the hardest part of the problem, being sure you understand that. Once you get those, you plug them in over here. So a, in this case, is 2x, and b is 5. So a plus b is 2x plus 5, and then 2x minus 5. 2x minus 5. And that's how you factor. This is called, I should have written it down, it's called a difference of squares. Okay, so these are both perfect squares, and difference means you subtract two numbers. So let's FOIL this out just to check. So this is the answer. So 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. 5 times 2x is positive 10x. And 5 times negative 5 is negative 25. So these two middle terms cancel out. 10x minus 10x, they go away. And so you have 4x squared minus 25. That's what we started with right there. So that's called difference of squares. Let's do another one. So for these, you kind of have to know what your squares are. If you don't, you just got to play with some numbers. 64 and 49. Well, since they gave them to you in the problem, you know that they're going to be perfect squares. The question is, what are they the squares of? So play around with it on your computer. Or on your computer, excuse me, on your calculator. And what you can do is find out that 64 is 8 squared and 49 is 7 squared. So I always want you to write out the formulas. That way you end up memorizing them, even though I don't require that you memorize formulas in the class. Okay, so this a squared is 64x squared, but to use this, we need to know what a is. That means we need to know what the square root of 64x squared is. So the square root of 64 is 8. And I'll show you how to do that on the standard classroom calculator, although I don't think most of you have this. It's a TI-30. So on this calculator, it's more complicated than other calculators. Some calculators, you just punch in 64, hit a square root button, and it'll give you the square root of 8. But this one, you got to put the square root symbol in first. So the square root symbol is, there's x squared right there. There's x squared. And that little symbol right above it is a square root. So how do you get to that symbol? That's the second button up here. That's why it's light blue. All these secondary symbols are light blue. So you hit second, and then you hit the x squared, and it gives you the little square root symbol with a parenthesis. Then you put 64, close the parenthesis. There's the parentheses right there. You just need to close it. And that's the square root of 64 is going to give you 8. Okay, so there's the 8 right there. You can do the same thing with 49 to get 7. So that's the square root of 64. The square root of x squared is x. So this is a. A equals 8x. B equals, again, b squared is this entire term right here. So if I want to get just b, not b squared, I have to take the square root of 49. That's 7. You can do it the same way we just did that. And the square root of y squared is just y. So you have two different variables in this problem, but that doesn't matter. Okay, so now we know a and b, so now we can plug it into this. So a is 8x plus 7y. And a again is 8x minus 7y. So there is the answer to this problem. And you can FOIL it. I'll do that real quick. 8x times 8x is 64x squared. 8x times negative 7y equals negative 56xy. You can't multiply x and y. They're different variables. So you just have to put xy, which means x times y. I'll put a little dot in between. That's what xy means, x times y. So it's really 56 times x times y. That's what that's saying there. Now, in this, the inner here is 7y times 8x, so that's plus 56xy. And finally, 7y times negative 7y is negative 49y squared. So the 56 minus 56 terms cancel out, and you end up with 64 squared minus 49 squared, which is the original equation right there, okay? So this is just a way to check it. All right, this is a U problem. Again, you have perfect square number there. X squared is a perfect square, and 1's a perfect square, right? 1 times 1 is 1. So that's a perfect square too. So you have perfect squares, so I want you to go ahead and copy the formula down that I just gave you in number 16, and go ahead and factor that out, okay? Difference, it's called difference of squares. All right, now we're going to get into one that deals with cubics. Okay, so number 18. First thing you'll notice is it's not a difference, it's an addition. And x cubed is a perfect cube. It's x times x times x. That's this. Now 64 is also a perfect cube. It's something times something times something equals 64. What is that something? Well, it can't be a very big number. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 3 times 3 is 9. Times 3 more is 27. So it's going to end up being 4. Again, you can just play with numbers, or I'll show you a little function on the calculator myself out. So it's going to be 3 second the hat, so that's going to be a cubed root function. It doesn't give me a beginning parenthesis there, so I can't put an ending parenthesis. So I'm just going to put 64, and then I'm going to hit equals. And it gives us 4. So 4 times 4 times 4 is 64, is what it's saying. Okay, so this question mark is 4. All right, so here we go. So here's the formula for this. It's crazy. It's a bit long. A to the third plus B to the third. You don't have to memorize this, but I do like you to write out formulas every time. Equals A plus B times A squared minus AB plus B squared. Again, you don't have to memorize this. You don't have to know how to figure this out. It's just given to you. Okay? So that's how you would factor this perfect cube. That's a perfect cube. That's a perfect cube. So if this is a perfect cube, what is A and B? Remember, this is A to the third. So x to the third is A to the third. That means A equals x. So let me write that here. So if I have A to the third plus B to the third, that means A to the third is x to the third plus B has got to be 4. That's 4 to the third, because that equals 64. All right, so x to the third equals x to the third, 4 to the third equals 64. So what I did, though, is I wrote it in terms of A. I'll put that in parentheses. That's an A right there. And this I'll put in parentheses as well. That's the 4 right there. Okay, so if I know A and B, I can simply plug in. This is always the hardest part, is figuring out the A and the B. Now I can plug it into the equation. So A is x, so this is going to be x plus B, which is 4. And then the A squared is going to be x squared. And then A times B is 4 times x. You always put the number first. So it's minus 4x. And then B squared. B squared is 4 squared. B is 4, so it's 4 squared. That equals 16. So that's the answer to that. All right, let's keep going. Again, just study these. You don't have to move quickly through this. Just think about them. Stop and think. Okay, is A a perfect cube? Yes, it is. 2 times 2 times 2. X cubed is a perfect cube. X times x times x. 27 is a perfect cube. 3 times 3 times 3. All right? So, in other words, this is in the form of A cubed minus B cubed. Now notice the other one was a plus. This is a minus. Let me try this again. The pencil's getting a little. So this is A cubed minus B cubed. So we got to figure out what A is, that when you cube it, it gives you that. So 2 is the cube root of 8. 2 times 2 times 2 would be 8. So I'm going to put a 2 in there. And x is the cubed root of x to the third, so I'm going to put an x there. And then I put a cubed out there. So 8x to the third equals 2x in parentheses. So what you're doing is you're cubing the 2 to get the 8, and you're cubing the x to get the x to the third. Then over here, we need b cubed. So what is b? B is going to be 3. It's the cubed root of 27 to the third power. So now this is the a component of this equation, and this is the b component, means part of this equation right there. So there's a and b. So a equals 2x, and b equals, it's 3. It's not minus 3. Okay, it's just 3. So here's the formula. You're going to see, I'm going to pull this down, compare it to the formula up above. So it's a to the third minus b to the third. That equals a minus b times a squared plus ab plus b squared. That's that. So look, compare the two formulas. The a to the a to the third plus b to the third, a to the third minus b to the third. The only thing that's different is this minus sign and plus sign right here. It's switched places. Up here it's a plus b, and then you find a minus sign there. Down here it's a minus b, and then you find a plus sign there. Otherwise, the two equations look identical to each other, okay? Again, don't worry about memorizing these. But now we're ready to just plug in numbers. There's a, there's b over there. So a is 2x minus 3. And then this term is 2x squared. That's going to be 4x squared. 2 squared and then x squared. Plus 2x times 3. 2x times 3 is 6x, so that goes right here. That's the a times b. And finally, the b squared is 3 squared, so that's plus 9. And that's the answer. All right. Let's keep going. All right, here's another perfect cube. You may not recognize it, but they wouldn't have given it to you if it wasn't. It's 5 times 5 times 5. There's a perfect cube, x times x times x. There's a perfect cube, 2 times 2 times 2. So the a here, again, the general equation is a cubed plus b cubed. And I'm going to put the a and the b in parentheses. So what do we have to put in parentheses here so that when we cube it, we get 125? Well, 5 cubed will 125x squared. 5 cubed will give us the 125, and x cubed will give us the x cubed. So you cube everything in here. Cube the 5 to get 125, cube the x to get x cubed. Plus, okay, 2 cubed gives us 8, so that's 2 to the third power. That's cubed. That's 8. So here's the a right there, and here's the b right there. So a equals 5x, b equals 2. So here's the formula again. See if you remember it. It's a cubed plus b cubed equals a plus b. Okay, and there you go. So now we just go ahead and plug in our a and our b. So a is 5x, b is 2, a squared is 5x squared. That's 5x times 5x, that's 25. 5 times 5, and then x squared. Minus 5x times 2 is 10x. 5x times 2, that's a times b. 5x times 2 is 10x, so minus 10x. And then finally, b squared. That's 2 squared, that's 4. 4. Plus 4. And that's the answer. Okay, so be sure you're not just copying, that you know how to do this, that you can do this on a test. Okay, that will be necessary. All right, one more. All right, so 2x cubed plus 5x squared minus 3x. None of the methods we've talked about so far would do a cubic like that, but you'll notice we can factor before we get started doing anything else. What do these all have in common? They all have an x. X to the third, x squared, x. So what we can do is we can factor out an x, and that leaves us here with 2x squared. X times 2x squared gives us 2x to the third. Okay, that leaves us with 5x here. X times 5x gives us 5x squared. And that leaves us with minus 3 there. X times negative 3 gives you negative 3x. So now we're going to set the x off to the side, and we're just going to do this the way that we did this before. So that's for a quadratic, for an x squared term. So remember that we find the grand product. So the grand product, GP, equals negative 6. So I'm going to come over here. We need to find two numbers that multiply to negative 6, and they have to add up to 5, positive 5. All right. So if they're going to add to a or multiply to a negative, one has to be negative, one has to be positive. So let's just start with -1 times +6. That gives you -6. And -1 plus 6 gives you 5. That's exactly the number. So we got it on the first try that time. So that's exactly. So these are the numbers you're looking for, -1 and 6. So remember what we did when we had that coefficient out there like that? We write 2x, not 2x to the third or 2x squared or 2x anything else. Just 2x and 2x. And then we take these two numbers and we put them down underneath. Okay, this one won't reduce, so it's simply going to become 2x minus 1. And this one reduces. 2 goes into 2 once, goes into 6 3 times. So it becomes 1x over 3. That reduced down to 1/3. And of course you don't write the 1, so it's just x over 3. So that means this polynomial is going to be x plus 3. Again, why that works, don't worry about, it just does. And I'm off screen a little, sorry, okay? So I got 2x minus 1 there. I got x. They're both positive, so it's x plus 3 there. And then you can't forget this guy. You kind of set him aside because you didn't need him to do that part of it. So you put that out front, and that's your final answer. Okay, and that's it. So that takes care of this lesson. It was just about 1 hour. Most of these will be. Try to do them yourself. So when you try to do them yourself, it could be an hour and a half, hour, 45 minutes. But try to practice these on your own. But I'm here to back you up to be sure that you know you're doing them correctly, okay? So go ahead and do this, and we'll talk about the due dates for this in class. And we'll see you next lesson.